Ever ordered something online and like wondered how it gets to your doorstep so fast and without costing a fortune?
Yeah, it's crazy.
Well, it's all thanks to the power of mathematical optimization happening behind the scenes.
Absolutely.
Today, we're taking a deep dive into this hidden world
Yeah.
and exploring how those crazy complex decisions are made using basically the magic of math.
It was wild, right? Like, what's really fascinating to me is that we're taking these messy, real world problems
Right.
and kind of building a math twin of them in this world of pure logic and efficiency.
Oh, interesting.
Yeah, and philosopher Roger Penrose, he called this the Platonic world, this realm of perfect forms and relationships.
So we're like teleporting our problems into a world with crystal clear rules
Yeah,
and solutions that are like optimized to the max.
exactly.
I was so intrigued.
It's pretty cool.
But okay, let's break it down. Our source material talks about the building blocks of these optimization models.
Okay.
Sets, variables, and parameters.
Yeah.
Where do we even start?
Think of it like constructing a model, right? But
Okay.
instead of plastic bricks, we're using information.
Okay,
Sets are like categories, helping us organize all that info.
I got you.
So, for example, if we're optimizing, say, a delivery route,
Yeah.
a set might be all the different trucks in a fleet.
Okay, that makes sense. So the sets, they establish the playing field, right?
Yep.
What about variables then? Are those like the players in the game?
Exactly. They're the unknowns, the quantities we're trying to figure out.
Okay.
So again, with our delivery example,
Yeah.
a variable could be how many packages each truck is carrying, or the best route each one should take.
Oh, okay.
And importantly, variables have these different types, each one perfect for a specific kind of information.
Ah, so it's like, choosing the right tool for the job.
Exactly.
Our source mentioned integer variables and real variables.
Right.
What's the difference there?
Okay, so imagine you're assigning drivers to these trucks, right?
Yeah.
You can't have like half a driver.
That'd be weird.
Right. That's where integer variables come in. They only deal with whole numbers.
God.
On the other hand, something like the amount of fuel in a truck
Yep.
that could have decimals, making it a real variable.
That's a good way to remember it.
Aha, glad to help.
Okay, so we've got our categories with the sets,
Yes,
our players, the variables. What about the rules of the game? That's where parameters come in, right?
precisely. Parameters are like the fixed values that really define the problem's constraints,
Okay.
like the cost of fuel,
Right.
the number of packages that can fit in a truck, or the delivery deadline. These are all parameters.
Got it.
They all shape our optimization puzzle.
So parameters are like the boundaries,
Yeah,
and we have to find the best possible solution within them.
exactly. They give context to our optimization challenge, but to
Yeah.
actually start solving it,
Yeah.
we need one more crucial thing, the objective function.
Yeah.
This is where we set our goal. Are we trying to maximize something or minimize it?
Right. Let's talk about this objective function. Sounds like the heart of the whole operation.
It really is.
I'm ready to get to the bottom of this optimization mystery. Okay, so we've like laid out the groundwork, right?
Yeah.
Sets, variables, parameters. We've even got our objective function telling us what we're aiming for.
Right.
But how do we actually like navigate this whole optimization landscape? How do we find the absolute best solution
Right.
with all these moving parts?
That's where we dive into the really exciting world of like optimization problem types.
Okay.
Think of it like choosing the right strategy for a game.
Okay.
Are you trying to rack up the most points,
Right.
outsmart your opponent, or maybe solve a puzzle in the fewest moves?
I like that.
Yeah, each problem type has this unique set of rules and, characteristics.
So it's not a one-size-fits-all situation.
No, definitely not.
What are some of these optimization game plans then? What can we actually choose from?
Okay, let's start with a really relatable one.
Okay.
Imagine you're trying to pack your suitcase for a trip,
Yeah, I've been there.
but you've got limited space, right?
Always.
That's basically the knapsack problem. You want to fit in the most valuable stuff without going over capacity.
Right.
It's like this classic optimization challenge.
I can see that for sure.
Yeah.
I've got this like love-hate relationship with packing my suitcase.
Yeah, I think we all do.
What other optimization games are out there?
Okay, well, there's the traveling salesman problem. Imagine a delivery driver, right?
Yeah.
They need to visit a bunch of different places in the most efficient order possible.
Makes sense.
That's a puzzle businesses deal with every single day
Oh, for sure.
to like minimize costs and delivery times.
Wow, so these optimization techniques are just like constantly running in the background,
Pretty much.
streamlining our lives from package deliveries to,
Wow.
overpacked suitcases.
Exactly. And it goes way beyond that, too.
Oh, yeah.
We're talking about like healthcare, where hospitals use optimization to schedule their staff really efficiently,
Oh, wow.
making sure the right doctors and nurses are free at the right times.
That's important.
Absolutely. Then there's finance, where optimization helps manage investment portfolios,
Oh, right.
maximizing returns while also minimizing risk. It's incredibly versatile.
Okay, my mind is like racing with possibilities here.
It's a big world out there.
But let's switch gears a bit.
Okay, sure.
Our deep dive also mentions something called constraint programming, or
Oh.
CP.
All right, CP.
Is that like optimization 2.0 or something?
In a way, yeah. So if you think of traditional optimization as having like a standard set of tools,
Okay.
CP is like adding this high-tech toolbox with specialized instruments
Oh, I see.
for tackling even more complex problems.
Interesting. What makes CP so special? What can it do that the other methods can't?
Remember those parameters we talked about?
Yeah, the rules and limitations.
Exactly. CP is amazing at handling these really intricate constraints,
Okay.
especially ones with like logical relationships or scheduling conflicts.
Give me an example. How would these intricate constraints actually play out in real life?
Okay, so let's say you're organizing a huge conference, right?
Yeah.
Hundreds of presentations, tons of rooms, all these different time slots.
Sounds complicated.
Right. You need to make sure speakers aren't double booked, attendees can actually see the talks they want,
Yeah.
and the whole schedule just like flows smoothly.
Sounds tough.
That's where CP comes in. It juggles all those constraints to make a workable, optimized schedule.
I see. It's like trying to solve like a giant Sudoku puzzle
Right.
where each decision like affects all the others.
Exactly.
CP can untangle those complex webs of constraints. That's amazing.
Yeah, it's pretty good at that. And that's just one example, really.
Yeah.
Our source highlights a bunch of problems where CP really shines,
Okay.
from optimizing factory production schedules to like designing complex logistics for transportation.
So it's about finding the absolute best solution within like a really tight set of limitations.
Yes. Kind of like a master chess player thinking many moves ahead.
This is fascinating stuff.
I know, it's cool, right?
But I got to admit, thinking about all these like complex algorithms and constraints, my brain hurts a little. Haha.
Uh-huh. Yeah, it can be a lot.
I mean, I know a bit of coding, but I'm no expert or anything.
Right.
Can a regular person like me really wrap their head around this stuff?
Oh, absolutely.
Or do you need like a degree in rocket science?
Haha. No rocket science required. While the actual math can get pretty complex,
Yeah.
the beauty of optimization is in its logical structure.
Okay.
It's more about understanding the problem you're trying to solve
Right.
and then like translating it into this powerful language of optimization.
So it's less about writing lines of code and more about like grasping the bigger picture,
Yes,
the
exactly.
logic behind it all.
Precisely. Think of it like reading a recipe versus actually being a chef.
Okay.
You can appreciate a well-written recipe,
Right.
understanding the ingredients, the steps, the whole process,
Yeah.
without needing to be a culinary master yourself.
I like that.
And it's the same with optimization. You can get the essence of the solution without getting lost in all the coding details.
That's like really reassuring to hear.
Uh-huh. Good. Glad to hear it.
But okay, speaking of different like recipes, what about all those different modeling languages? Our source mentioned things like Gurobi and CPLEX,
Yeah.
even Python. It seems like a whole other language to learn.
Yeah, it can feel kind of overwhelming at first.
For sure.
But here's the key thing.
Okay.
The underlying logic of optimization.
Yeah.
It totally goes beyond those specific languages.
Okay.
It's kind of like music, actually.
Oh, okay. Think about it. You can play the same melody on a piano, a guitar. You can even play it on a kazoo.
Uh-huh. Right?
The instrument might change, but the actual musical structure, the melody itself, that stays the same.
I like that. So it's more about understanding the melody of optimization
Exactly.
than like becoming a master of every single instrument.
You got it. Take the capacitated facility location problem, for example.
Okay.
It doesn't matter if you're coding it in Python, Julia, or some specialized language like AMPL.
Right.
The core challenge is the same.
Okay. And what's that?
You're trying to decide which facilities should we open? How should we like allocate resources? And how can we best serve our customers?
Makes sense.
And of course, you got to do all that within your budget and capacity.
Oh, right. The constraints are always there. Exactly. Always got to keep those in mind.
So once you like really understand that optimization recipe,
Yeah.
you can then adapt it to different languages and tools depending on the problem you're trying to solve.
Precisely. The syntax, the actual code, that might change.
Okay.
But those core elements,
Yeah.
your sets, your variables, those constraints, and your objective function,
Right, right.
those all stay the same. It's really about translating your understanding of the problem into this, like, very powerful mathematical framework.
This is making me realize that optimization is less about being like a coding whiz
Yeah.
and more about being like a strategic thinker, a problem-solving maestro.
I love that analogy. That's a good one. It is about seeing the world through that optimization lens,
Right.
identifying those areas where you can like improve things, make them more efficient. Yeah. And then using these really powerful tools to actually find the very best way forward.
Well said. Okay, so as we wrap up our deep dive into this fascinating world of optimization,
It has been fun.
what's like the one big takeaway you want our listeners to walk away with today?
That's a good question.
Yeah.
Let's say this. Optimization isn't just some, abstract mathematical concept that's stuck in textbooks and research labs.
Right.
It's actually woven into everything. It's in the fabric of our daily lives.
Wow.
Seriously. Like, the next time you use a navigation app to find the fastest route,
Okay.
think about it. That's optimization algorithms working their magic in the background.
Oh, I see it.
Or when you see a delivery truck that's packed perfectly. Remember that knapsack problem we were talking about? It's everywhere.
It's like this hidden world is suddenly becoming visible.
Uh-huh. Exactly.
And it's all thanks to this like new understanding we have of optimization.
It's pretty cool when you start to see it.
For sure. And, as you become more aware of these like hidden systems,
Yeah.
you might even start noticing optimization opportunities in your own life.
Absolutely. You're going to start seeing them everywhere, I promise.
That's awesome. Like whether it's something small like streamlining your daily routine
Right,
or
exactly.
making some big complex decision with tons of factors at play.
Optimization can help with all of it.
That's a great point.
Yeah.
It's like our world just got a whole lot more optimized.
I like that. I'm going to steal that one.
Uh-huh. Go for it. Even if it's, just in our minds for now.
It's a start.
To all our listeners out there, keep your eyes peeled and your minds open.
Yes.
You might be surprised by all the optimization puzzles hiding in plain sight,
They're everywhere.
just waiting to be solved.
Go get them.